All right, today I want to do some experiments on the additive properties of light using my very cool new lights from the Missile Defense Agency for STEM educators. Thank you so much, MDA, with a blue light, a red light, and a green light. Now they have magnets that I can use, but I'm finding that it's better to just use them kind of individually. And they're not lasers, they're just special flashlights that have that kind of line where the light passes through. So I want to see what happens when I add these lights together. I'm going to do 3 experiments today. First, I want to see what happens when I combine blue and green light. Then I want to see what happens when I combine red and blue light. And then I want to see what happens when I combine all 3 together. Now we're looking at the electromagnetic spectrum, but really we're just focusing on the visible part of the spectrum for these experiments. So here's green by itself and blue by itself. And when I add them together, what do I predict? Okay, what do I predict is going to happen? Let's record that. Since we are scientists, we record our predictions and our observations. I think green and blue is going to be like kind of a, I don't know, maybe a sea foam. Red and blue, I'm going to predict as purple. And when I combine all 3, I don't know, maybe like a brownish. I'm just thinking of when I combine paint, right? But let's see what happens when I combine the light. In fact, I'm just going to go ahead and move this. All right, now if I come closer, further apart, it may show up differently in the document cam, but these are very like rectangly defined shapes, very blue, very green. And when I add them together, I get almost a light aqua. You can see where they intersect. So the first thing I observe is it gets brighter. Like it is substantially brighter. It's like you take all this brightness and you combine it to get it even more bright. Okay, and it's not white, but it's definitely not darker. So let's record our observations and say that, and this would be a great place to have like a photography or some other qualitative data collection measure instead of just my drawings, because this is very kind of basic, but it is a sketch with a label, and that's what matters most. So I'm going to say brighter and lighter. By lighter, I'm going to say light blue-green mix. Okay, and notice my sketches are not very amazing. Okay, that they don't have to be, as long as I'm doing the science and recording my observations. All right, green, go away for a sec. And let's see what happens when I add red. So looking at some of those observations there, I can move them apart. Okay, nothing too different about this. Maybe the red seems a little bit brighter, I'm not sure why. Okay, let's see what happens when I combine them. Okay, so I've got the red here, blue. Let's see if I can get them close to the same shape so it's a direct overlap. Okay, now combined. Oh, it's cool. It looks like the TikTok logo. It's a color sep look. Okay, color separation filter in Photoshop and Canva is based on this principle, where red and blue are among the primary colors, and when separated you get this kind of white in the middle. But if you match them up just so, it's not purple, it is brighter. I would call this more of a magenta, and it is brighter. And I'm also, I don't know if this shows up on the document cam, but I'm seeing kind of like a more succinct border, if you will. Yeah, okay, so let's record those observations. When we have blue plus red. Okay, I don't get a purple. I mean, it was a light purple, but I mean, purple doesn't really, it's not a scientific name. Magenta is the scientific name for that color. I know that from my research on the color wheel. And I'm going to make that kind of a thicker border, and it was bright. It was definitely brighter. All right, nice job. Now let's take a look at the prediction for that, for combining them all. Okay, let's see if they get brown. Now this is very tricky to do. Green, red, and blue. And I wonder if this is where I'm supposed to use those magnets, but that's okay if I don't. I'm just, oh, that's right. I just realized I might be in the way. Okay, here we go. I have to hold my hand just right. Oh, wow. So on the border, maybe just because of the way I'm hand holding the lights, there's definitely like a spectrum along the border, but for where all three lights are interacting, overlapping, it's almost white. It is white. Now, there's a lot of operator error here. There's a lot of margin of error. Let's see if I can line them up in a way. There we go. Get a little more accuracy there. So this is a cool view because I can see on the right where it's red and green, and on the left where it's blue and green. But when all three overlap and combine, you can see that white light, because light is additive instead of, it's not like paint where the colors are taking away from each other. They're adding to each other. This is the same as a white light hitting a prism and separating it into little rainbows, except it's in reverse. Okay, so let's record that. And I'm just gonna do this one because I thought that was really cool. So this is the entire line, but here is where well, it was more than that. About here was white, red, blue, and this whole bit was green, and there was overlap of like green red in there and blue red in there. So again, this is a place where qualitative data is more important and more useful, and it'd be helpful to use like a camera and other recording softwares to help record those. Now let's look at prisms. Okay, I've got this prism, a rhomboid shape. Got a convex prism and concave. I remember that because these are caved in, and that means the other one is convex. And I'm not really going to record my my predictions here. I'm just going to play. So I've got blue, red, green. Okay, you can kind of see that white. And let's just see what happens when we play with these prisms. Starting with concave. If I put it here, I can see that light might be bending as a result of going through the through the prism. And it might have something to do with the shape of the prism itself. Either way, this prism is refracting the light by bending it along the direction that it's manipulating. So you are seeing firsthand an example of refraction. Same thing for when you have a straw or a fork in a glass of water, or maybe a spoon, and the light looks like it's bending the spoon. It's very similar. It is the same principle that you're observing here. You can really manipulate it. Your eyeball works the same way by having a refractive lens on the inside. So your eyeball is adjusting for the light as it comes in, and then focuses it based on this principle of refraction. Let's compare that to convex. I don't know if it's showing up in the document cam. There is some bending for sure, maybe in a slightly different pattern, but I'm also seeing the pattern of the prism itself reflecting possibly on the box. So I'm getting a lot of interference, which is interesting, but not intended. Okay, so there's all sorts of different ways to experiment with pulling light together additively to make new colors, as well as to bend it. And finally, the rhomboid. Now this one's just cool because it comes up with all sorts of awesome patterns that I don't really know how to describe. That's why I record my observations and go look them up later on and get even more research to back my observations. So I suspect this rhomboid shape, because it's got parts of it that are regular and parts of it that are irregular, creates some unpredictable patterns as a result of this. And talk about adding the A into STEAM, right? Putting the art into STEM. There's just no such thing as doing science in a vacuum, because science and art go hand in hand, whether we want them to or not. All these are just natural observations of phenomenon that we're experimenting with. So I don't know what's coming up on the document cam here, but I'm seeing a big difference, especially in this green light, with how, maybe because I really can't explain why, but at least from my viewpoint, it has a bent ray of light, very different than the green or blue or red coming out of it. And I don't know why. I'll have to look that up. All right. Well, there we go. I think we can at least record that we can look at refraction based off of different shapes of prisms. Concave, convex, which to me had the most obvious light bending changes, rhomboid, like this, when I had, could really use some colors here. So I had blue, red, green, and when they came together like that, then when we moved the thingy, it changed the direction of the light. So I would definitely need to use some colors here in my note taking to show that the convex had the green kind of coming out of here and then bending the light to come out of here, etc., for the blue and the red. So I am now a scientist because all I've done is add predictions and observations recording to my experimentation. Thank you.